The Wolfram language includes a general system for accessing information about the real world and in particular for representing that information in a way that can be used in computations. The basic ideas are fairly simple. For example, here's an input that computes the mass of a ball of lead, which is done here by multiplying the volume of the ball by the density of lead. A critical piece of real-world knowledge in that input is the density of lead, which was entered using the natural language system by typing control equal to get a box for entering natural language input, and then typing density of lead into that box. Pressing the return key or clicking outside of the box causes that natural language input to be translated into a form that can be used in computations. The result displays in an iconized form, and evaluating that input returns the density of lead. The structure of that input before it's evaluated is also of interest and can be seen by using hold to hold the input unevaluated and displaying the unevaluated input in input form, which shows that the input is based on entity and entity property. The lead icon is the displayed form of an entity expression, and the density icon is the displayed form of an entity property expression. That example shows a typical structure for representing real-world information based on the idea of organizing that information into properties of entities. The density of lead, for example, is obtained by entering the entity, which in this example is lead, followed by the desired property enclosed in square brackets. The density property can also be specified using the string density, which is the canonical name of the property. The canonical name of a property can be obtained using the canonical name function. A value for a property can also be obtained using the entity value function. For example, this input shows the entity value function with the entity as the first argument and the desired property as the second argument. These different ways of specifying properties of entities are often interchangeable, although there are some differences. The first argument in entity value can, for example, be a list of entities, as in this example, which returns a list of properties for a list of entities. Some entities have lots of properties. The entity properties function returns a list of the properties of an entity. This input, for example, shows the available properties of lead. Rather than locating a desired property in a long list like that, it's often more convenient to use the natural language system, and knowing that the natural language will typically be translated into a properties of entities format can help guide the choice of natural language, even when entities and properties are not used explicitly. For example, the specific heat of fusion property of lead can be obtained by typing control equal and specific heat of fusion of lead, all in natural language, which translates into the specific heat of fusion property of lead, and that input can then be evaluated to get the desired result. The command completion system can also be helpful in selecting properties. For example, entering the lead entity followed by a square bracket brings up a command completion menu. The first item in this menu is properties. Evaluation of this input with properties as the property gives the same list of properties as was returned earlier by the entity properties function. Typing the first few letters in the canonical name of a property shows only the properties that start with those letters. The desired property can then be selected from the menu. For example, this shows the result of choosing specific fusion heat from the command completion menu. Many entities are grouped into classes. For example, typing control equal and chemical elements returns an icon that includes a grid of dots. The grid of dots indicates that this is an entity class expression rather than a single entity. The entity class expression can be seen using input form. The second argument in entity class provides various ways of specifying the elements that should be included in the class. For example, this input uses the natural language system to ask for the first 5 chemical elements, which gives an entity class expression where the second argument is an expression that picks out the first 5 chemical elements ranked by atomic number. The actual list of elements in that class can be displayed using the entity list function. Some entity classes with a large number of elements automatically return only part of the list. For example, using natural language with list of mountains translates to entity list for an entity class that includes only the 5 largest mountains ranked by the value of the elevation property. It's possible to get all of the elements in the class by using all as the second argument in the entity class function. The entity count property of that class returns the number of elements. There are a few common cases where real-world information is accessible using separate functions. This input, for example, shows the anatomy data function used to get a 3D graphic of a particular bone, the left femur. Graphics 3D is a property of the left femur entity. The same result can be obtained by evaluating this input, which uses the structure with an entity followed by the property enclosed in square brackets. So the anatomy data function is, in this example, just a different way of accessing this information. Here's a similar example which shows the use of the city data function. And again, the same result can be obtained using the corresponding city entity and country property. There are also a few special cases of real-world data that is not a property of an entity. For example, local time can be found using the local time function, and the air temperature at a location can be found using the air temperature data function. Additional information about accessing and representing real-world data can be found in the Wolfram documentation by following links from this guide page on knowledge representation and access.